All right. Check for the sound. All right. So no. Oh, here's people coming in online. Okay, good. All right. So let me get this thing up. All right. So might as well say a few things about the news. There was a big event here with pizza for people who just graduated, but they're clearing out. So all right. So this is the last class. The final exam, I think, is already up. It's up for a week. You do not have to take it, but it's worth about 80 points if you do. If you have enough points for the grade you want without it, you don't need to take it. Anyway, there's lots and lots of exciting news. Stuff that just happened. This one's kind of fun. And this is the one that just happened. And that's pretty cute. That's good, clean fun. And it's not that exciting. You don't really know what that means. Anyway, so this is the big new exciting thing is Zombieland. And every, oh, I got to find the pretty one, Zombie Load. I'll just Google it, Zombie Load. Every,
just the data lab in memory, right?
Yeah, what these are all, every logo, every vulnerability now has to have a logo and a name and a website. I don't know why they don't have like a dance move and a flavor at Starbucks, but I guess that's the next thing. So the Zombie Load is just another in the Spectre and Meltdown series. And the point of this one is if you have hyper-threading turned on, that means one processor core does one chain of instructions, and then it switches to another, and it shares the registers and the cache. So, of course, you can do a side channel attack and find out what the other thread is doing by checking to see what's in the cache, which is how they all work. And this is all performance versus security, which is the way it always is. To make the processors faster, different parts of it share resources. If you had everything totally air-gapped, like a totally separate processor, then it would be a lot harder to steal the data, but that would cost a lot more. So if they share resources, it's faster and cheaper, but then there is some possibility of information leakage, and that's the whole mess of Spectre and Meltdown and a chain of others. They said others would keep getting found, and these got found, and the patches are coming out. And there's some demonstration code that's supposed to run on Windows and Linux, but I couldn't compile it on the Windows down there, it crashes. You know, but anyway, they have some videos of showing it. It's just the videos are all pretty boring. You run a process, and this run another window with a different process, and it steals the data out of this one, so a word appears. You know, it's not super exciting. Previous one, the original one, they had like stealing your password from a browser. That was more fun. But they can do anything. Anything you supposedly it's isolated into one process can in fact be stolen by another process with these attacks. And we'll talk a lot more about that when we get in the lecture, because Apple makes a lot of effort into isolating things, and it's also failed. So this one, I was talking to somebody, and they were arguing on the other side. I thought, you know, my parents taught me some concept of free speech, which apparently is no longer commonly believed here. But anyway, so this guy, this is Harvey Weinstein, you know, accused of sexually molesting a bunch of women, and this guy is a lawyer. The lawyer is a famous lawyer. He works at Harvard, and he took the job defending this guy. And so they are firing him, blacklisting him. Students are dropping in classes. They're throwing him out for daring to defend this guy. And I'm like, but he has to have a lawyer. We have a system here. Instead of just having a lynch mob where we don't like somebody, so we lynch him and we spit on his grave and call the job done, we actually have this process where you go to court and have a trial, and you have a defense lawyer, and you're innocent until proven guilty. But apparently this is not knowledge that's known at Harvard anymore. So I was surprised. They're punishing not only the guy before his trial, but his lawyer, who even if you're guilty, you deserve to have a lawyer. Somebody has to do that. You don't punish a lawyer for daring to defend the guilty. That's their whole job description. Well, anyway, so it's an interesting thing to argue.
The right to protest, right?
Oh, you can protest, but they're actually like kicking him out as the dean and firing him and everything else. So I mean, the administration is joining. This is the same thing that happened here. The same thing happens at every college I know. If anybody complains, they just fire everybody to make the complaint go away. Justice means nothing. This is always been the case in college and high schools. At the college level, it's sometimes a little different. although it tends to be just the same thing. They just bow down to whatever seems to be the mood of the moment to try to stay popular. Anyway, I thought this is pretty good. They built this gadget in China, and the point of this is it makes it look like you're walking, and you can get a discount on your health insurance for walking enough steps every day. And apparently this is also true in America, that there are health plans that give you a discount if you install this app and walk enough. I know I saw these, you know, I looked into MetroMile. MetroMile is car insurance for people who don't drive much. It'd probably be cheaper, but you have to install this tracker in your car, and it watches to see if you're driving safely. I'm thinking of getting it because that would suit me fine, but it totally watches if you're going too fast, and it increases your insurance, which, you know, is people complain about Big Brother, but that wouldn't bother me. I'm the typical boring old guy driving too slow, irritating everybody. It would suit me just fine. Anyway,
How much is that?
they gave me a quote, and they said it would go down to like 20 or 30 bucks a month, depending on how much you drive. I don't know. They didn't say it, but it seems like a pretty good solution. Anyway, you could just take a clock. I mean, you could make your own. You could easily make one. Yeah, yeah. You know, the Tibetans have these things that the prayer wheels that rotate. You could just have one say in your yard. Sure. I just get a grandfather clock and tie it to the. Anyway.
Also, people like taking under their fans for Pokemon Go and stuff because, like, the eggs, if you walk around, they hatch.
Oh, they have. Oh, good. Yeah, good. Yeah. So this is what just happened. Just a few hours ago, Trump declared a state of emergency to make it a crime for American businesses to do business with Huawei. And this means not only the government can't use it, but apparently nobody can use it. And the business partners can't sell parts to any Huawei phone or use any parts from their suppliers. I mean, no, as usual, Trump just probably spit this out on Twitter and nobody knows what it means. And nobody knows if it's really going to happen, I would imagine. That's typically what happened, like the transgender ban in the military. He tweeted this and people said, "What are you talking about?" And like Comey got fired and he's like giving a talk at a meeting. I said, "You just got fired." He said, "What do you mean I just got fired?" They didn't check Twitter. He said, "Wait a minute, that can't really count, does it?" And it's not really clear whether that counts. Anyway, but so this is more hot water with China. The trade war with China is really heating up. So we'll see what comes of it all. It looks like we're going to go to war in Iran. They're really trying to, and I thought that was the interesting article. Our British allies are totally not on board with that. Well, it would be interesting to know. I mean, the point is, this is what people said would happen when Bolton became the national security advisor. They said Bolton was a lunatic that just wanted to have a holy war on Muslims, and that's where he would start a war. And when it didn't happen, I thought that wasn't true, but this does seem to be finally happening. And it's very bold. He was involved in the last one, the fake weapons of mass destruction, when they accused Iran of having these weapons and they weren't there, and they rushed to war. Bolton was in on that, and he's doing it again. And the British are saying, you know, Iran is not doing anything different than they ever have. They're kind of annoying, but it's not like anything's any worse than it used to be. And suddenly you're like deciding to get mad about what they've been doing all along. And there's no reason to like rush into this military posing, but we're totally there and they're totally punching back. Now Iran has said they're going to start enriching uranium again to get even with us. So, you know, we're ramping up the pressure. Maybe we'll have another war in Iran. I really don't think that'll do anybody any good, but the one good thing about Trump is Trump doesn't really want a war. They say it's Bolton doing it, and Trump is, well, Trump just sort of being dragged along unwittingly. Like Trump didn't even mean to make Steve Bannon the national security advisor. He just put that on paper and put it in front of him to sign without reading it. Trump doesn't really know what he's going on much, but I think he does really not want to have wars with other countries. He actually isn't starting wars, and I think Bolton will do all this, and Trump is like not paying attention, and when he pays attention, he might stop the war, but, you know, anyway, hopefully that won't happen. Anyway, let's talk about iOS. So I've got some slides, and iOS is good, clean fun.
If it does start, it'll be a good legacy for Trump.
Well, I don't think it'll be a good legacy, but it'll certainly be a fairly common one. We've had many, many wars with Iraq and Iran to no apparent benefit that I can see, but we.
I don't know, this war and this country cannot do much with any money anymore. There's no money for anything.
Well, I don't know. The billionaires seem to be doing just fine, and the companies and everything. There's a lot of money around. There's a bunch of people that don't have their share, but we got plenty of money. And all you have to do is announce a cryptocurrency, and billions will fall from the sky on you. There's a bunch of money just flying around in America in the hands of complete idiots that will spend on anything. We're not short of money in mass. We're short of sense. Anyway, So, all right, anyway, let's talk about iOS. So this is the last bit. So security model, and the data, they were down to the data protection API and the keychain and TouchID and the binaries. And I'm very pleased. It's very much like what we've done with Android, just slightly different tools. The only thing is you must have a jailbroken iPhone, which I don't have this semester, but I should be able to make it by next time I teach this class in a year or two. So the data protection API is here. I was surprised. In 2010, banks actually cared if they stored your data locally unencrypted. I could never get anybody to care. But at this time, Citigroup was so embarrassed, they actually updated their app and everything. They thought it was terrible to store your data with no encryption on the device, which that would be swell if people felt that way. So iOS has a fantastic amount of encryption, far more than Android. It is the most complicated, multi-layered encryption scheme I've ever heard of. Tom Horvath, when he developed his jailbreak, he taught me this stuff, and I couldn't believe it. It is really heavily encrypted with many different layers of security, and it's very effective. There are no rootkits, almost no malware. It's really hard to pirate stuff. You know, it's very effective. So anyway, they have these, and it uses this encryption. This is how it protects you, which is really pretty clever. So you have a secure enclave in all modern devices, which is the air-gapped special chip to hold the secrets. I think it's air-gapped. I don't think it's just virtually air-gapped on the same chip. I think it's a separate chip like the trusted platform module on a motherboard. And then the place to put secrets, because it's not anywhere in the address space of the processor. So even a kernel exploit with root privileges on the processor can't steal the secret, because the secret is not directly addressable. All it can do is issue a command to this chip, please decrypt this part of memory, which it will do, but you never see the secret key. The secret key is on that coprocessor, and it never enters the address space of the processor, and that is considered very good. The only attacks that leak it out are an exotic one we talked about last time, where you do some kind of side channel attack, and ones where you dissolve the chip with acid. You know, you have to do something heroic to steal the data off of that thing, because it really is pretty secure. And it also has a key based on your passcode, so that it's not just the device itself, but something you put in is used. So what they do is they run it through this PBK DF2, and that is nothing but the password hashing function used in Linux. All that is assault and then 5,000 rounds of SHA-512. That's a way to make a long, random-looking key from some data like a user's passcode. And this includes a key specific to your device, the UID key, which is embedded in an onboard chip. So this means even if two people use the same passcode, their passcode key is completely different. And it's tied to that device. And you can't take the passcode key from one device and move it to another. You know, it's really, they seem to have thought of everything. And this is the layers of encryption. So you have the built-in UID key, which is like a MAC address built in on your phone. And you have the passcode that you type in. Then it combines them and makes a passcode key. Then it has a device key. And then it creates a whole bunch of keys for different categories of protection. And each file is protected by one of or more of these encryption keys. And what it does is it deletes the key. Like when your phone goes to sleep and you have to wake it up and log in, it deletes the key so that the files that are not supposed to be accessible while it's asleep are no longer accessible. And that is pretty clever. And when you do a wipe on your phone to restore it to factory defaults, or a remote wipe, it just deletes one of the master keys, so all the data is gone. That is the real cool way to do it. In just one small write operation, all the data is gone, and it is in practice extremely effective. So
when you wake up,
yeah.
you generate all those keys, right?
Yeah, when you wake up, you have to log in, and then it regenerates the passcode key. But this stuff, for the complete protection stuff, is encrypted by a key that requires the passcode key, and the passcode key is deleted from memory. And you can't recreate it without re-entering your passcode. That's a pretty clever system, in my opinion. It's very simple. There's no way to get in without your passcode. The device has forgotten the key, and it cannot rebuild the key without your passcode. That seems very smart. Of course, we're going to see TouchID fouls it up, but anyway, it's the way it always is. You have a beautiful system, but if you want to make it easier to use, you have to lower the security. That's the way it always is. Yeah.
When you say wipe it, does it wipe the key data too?
Yeah, I think when you wipe it, I think it deletes this one.
Okay.
And then you lose everything. That's why I'm not quite sure which one, but that's what they say. Root wipe just deletes the keys, and then all the data is gone totally.
The file keys are still there, right?
I think he deletes them too. You're right. He has to delete these two. Delete that and the keys below it, of course. Otherwise, that wouldn't do it. Yeah, it's a good point. All right.
What's the difference in bricking them again?
Well, bricking it is when you break it so it won't even boot up. That's when you would break the operating system files.
So the Mac people can't restore either, right? Just to like.
Well, I don't know. I have never heard of someone fixing a bricked iPhone. I know you take it to the Genius Bar and they do something. So it's this, what if someone steals the computer you originally paired with your iPhone? That's a good question. I think even so, if your iPhone is asleep, you still can't get in even with a computer connected, but I'm not really sure. I know if you have iTunes synchronization, you might be able to wake it up from the computer. I do know there were some viruses that took over iPhones by attacking the Windows PCs they were paired to, not the phone itself. They would infect your Windows machine that you had iTunes on and then suck the data off of that. And that's pretty clever, and that will, of course, work. Another thing, which I've never heard of, but I wonder if it would work, is you could get a Windows ransomware attack and infect the iTunes and corrupt your data on the phone. I've never heard of that, but that would seem possible to me. You could corrupt your stuff, and then when you do an iTunes synchronization, it'll get it corrupt. Anyway, it's a good question. When you connect it to your computer, of course, you've got another attack vector there. It's a very good question, and it'd be fun to play with that. Anyway, so here's the protection classes. You can have files that have no protection at all, never encrypted, but the complete protection is the one where as soon as the device is locked, it waits 10 seconds, and if it stays locked for 10 seconds, then it deletes all the keys, and now all that stuff is inaccessible until you re-enter the passcode. And you can also have a level where you let the file remain open even when it's locked, because you might want to have an app that keeps running even while it's locked, and it wants to keep the files open, so you can set that up if you want. And there's you can also have this one, which is the default, complete until after first user authentication. So when you turn the power off completely, everything is locked, but when you first log in, it unlocks it, and it stays unlocked all the time from then on, because this is the lower level protection, but that's the default. The higher levels you turn on if you want them, but this is considered the default. I suppose it might be just to save battery life, so you're not constantly encrypting and decrypting things. I'm not really sure. Anyway, so then you got the keychain. Now the keychain is where you store secrets like passwords and stuff on macOS and on iOS. And the keychain has a whole bunch of the same classes. The same general principle is there. You can have accessible always, accessible only when unlocked, accessible after first unlock. And then you can have another bunch of settings for whether you want it to be able to migrate to other devices with iTunes. You can allow that or you can block that. And you can have various settings here, and it's all done by manipulating the encryption keys the same way, which seems to be a very simple but very effective system. And now you got these modern access control and authentication policies. And the point of these is just like on Android, you may remember when you tried to put on a secure certificate so you could go through burp, you had to put a passcode on the phone. It won't let you add security features until you turn on a passcode. Same thing's true of iOS. They won't let you do any fancy stuff until you put a passcode on, which of course makes sense. Like encrypting something when there's no passcode is stupid, and they won't let you do it. And then they added TouchID, so you can authenticate with your fingerprint. And of course, that is much less secure. There are a bunch of attacks against that. Now, the keychain itself is just a database, and if you jailbreak the device, you can totally just dump it. But of course, that would assume you've logged in with the passcode. And TouchID is fingerprint authentication. So if TouchID is not enabled, then the way it works is your enclave kills the keys, and when it's locked, it destroys the keys. And the only way to get the act is to log in again and put in the passcode so it can recreate the keys. That's fine, and that's what sounds like a very secure system. But if you have TouchID, it can't do that. It doesn't delete the keys. It encrypts them with another key, a wrapping key, which comes from your fingerprint. And now you get your fingerprint, which unwraps the key, but the key is still sitting in RAM, available. This is how a lot of devices work. There was a vulnerability report last week of encrypted, highly secure USB devices sold to be unhackable. Worked this way. They had a password that was sent to the device, and they had an app where you type in your code, and when you typed in your code, it would send a password to the device, but the password was always the same, and you could just sniff it and get it. All the security was in the app, and the actual device just worked with a hard-coded password that never changed. So once you found that out, which you could find with just Wireshark sniffing USB traffic, then you're hosed. And this is the way a lot of encrypted hard drives have been. Because the reason why it happened to hard drives, by the way, I went to the Pacific Hackers Conference and they talked about this. The first generation of encrypted hard drives, and after several years afterwards, all had horrible encryption like that because for some reason, the official government standard for hard drive encryption is bafflingly complicated. Instead of just saying there has to be like a password and you can't get in unless you have a password, the official standard is it has to support multiple users that each have their own separate area of the drive and a shared area. So you somehow have to handle a bunch of keys. And so everybody found that too hard to put in the firmware, so they would put that in the app and just have one password going to the actual drive. And of course, that means you can just hack the app with any technique you want and get in. But this is why you do it. And it's sort of like that Android app we saw last time, where you have an app where they actually download the whole database of passwords onto the phone and then try to log in here. We had a couple apps like that. And what's going on is somebody only understands how to program the phone. They don't understand how to program the server, so they just do everything on the phone. And it's the same kind of thing here. You do everything in your app and just have a dumb drive, rather than figuring out how to actually program firmware on your drive. Anyway, and so the Chaos Computer Club broke the TouchID. A bunch of this stuff came out. I know facial recognition, you can totally just put up a picture of your face. And if you are black, then it doesn't recognize you anyway, and it gets the wrong face. You know, just like you'd think. And the fingerprints are just the same. These guys found I can just take a photograph of a glass you've used with your fingerprint on it and print it and make a fake fingerprint. Of course, I mean, mine's very irritating. Mine fails, in the morning it's cold, it fails like 3 times out of 4. And I have to log in with my password. So it's already irritatingly accurate. So I'm sure they lower the accuracy way down so it doesn't irritate the real user. And I'm sure anything even halfway close to your fingerprint will get through. I wish it was less accurate, because I'm annoyed by having to type in the password so often. I frequently erased the fingerprints and re-encoded the fingerprints trying to get it right. And still, even though I filled all 4 possible slots with my one finger over and over and over, it still fails a lot. Probably my fingers are too big or something. Anyway, so then there's the binaries themselves, which is all very, very much like Android. Very familiar territory. You have these MockOh binaries. Now, the one thing that's different than Android is they really are machine code. In ARM code, they are not high-level code like Smalley. You don't just have, but they're compiled just like Windows x86 Act, except for ARM. So you've got this MockOh binary. MockOh is the format. Portable executable is Windows, and ELF is Linux, and for some ungodly reason, they use MockOh. All approximately the same thing. You've got a header, which specifies the file format and which architecture, which means which version of the processor you're using. Then you've got load commands here to tell you about the memory segments and whether they're encrypted and where the library files are, just like you would in ELF and Windows executable. And then you have their data segments. And that's the file, so it looks like this. You got a header, some load segments, and data sections. Very much like a PE file is the same thing. And we'll go through it next semester for Linux and Windows. If you take 126 and 127, that's what we're doing mostly, is analyzing these files and learning how to exploit them. So now this has fat binaries, which I must say is like the Home Depot app, that horrible project I had to pull. If you downloaded Home Depot, you would get 4 different versions of the app frequently for different versions of hardware. And this is apparently quite common for iPhone apps. There's ARM v7, ARM v7Fs, and ARM 64. So if you want to write an app that covers all these, what you typically make for some unknown, instead of just having 3 versions of the app, which is what I would have done, it has a fat binary that includes 3 copies of the app for different versions in the same binary, which is, I don't know why this is the best way to do it, but that's what they do. They call that a fat binary. So you can use Otoole to look inside and see what architectures there are there. And here's Otoole running on an app, and it shows that here's one that is ARM, and here's one that is this number, 1677, that's what ARM 64 turns out. Another irritating thing. ARM v6 and ARM v7 and ARM v are 12 and subtype 1, but ARM 64 is 16777. So, you know, I don't know why that made any sense to anybody, but that's what it shows you for ARM 64 is 16777. Yeah. Anyway, that's the way it is. So Lipo is the tool that will suck out one of those small things from the fat binary and make it skinny, which I thought was pretty cute. So you lipo the fat binary to make a skinny binary. And that's how you pull out just one version if you want. Anyway, so that's the joy of that. So once you've done that, now there are security features in here. Everything since iOS 5 has had Pi turned on, which is position independent executable. We've talked about it before. This is the necessary support, so there is no absolute addresses in it. Everything is relative, so it can be relocated in memory and it will still run. You can't really get much good out of ASLR unless your stuff is Pi compatible, and everything is Pi compatible by default, so only really old apps wouldn't have that. You can check with Otoole to see if the Pi is turned on, but anything that's not like really old should have Pi turned on now. Stack smashing protection is just like it is in Windows. It puts a canary at the end of the stack frame. So if you overflow a buffer, it will detect that because the canary value would change. Also, just like Windows, it doesn't always use the canary. Apparently, the canaries are expensive because both Windows and Linux compilers do this. And the Apple and the iPhone compiler too, apparently, it only puts the canary on functions that appear risky. And usually it's functions that have a string variable. I know in Windows, you have to have a string array longer than I think 4 bytes, or it won't put it there. Because it figures you aren't likely to have buffer overflow, so you have to have a string array. And apparently it's just too much bother to put a canary on every stack, which is what I would have done. But it does pick the ones where it wants to put it. So that's protecting you from the classical stack buffer overflows. And then it has automatic reference counting, which protects you from heap overflows. The heap, the point on the stack, is where you put data that is used only in a subroutine, and when you return, it's all thrown away. The heap is where you have used data that has a less structured use, where you reserve data with a allocate command, and when you're done, you free it with a free command. So you can reserve any temporary piece of data and free it under your own conditions instead of the stack, which automatically reserves it when you enter a function and automatically frees it when you come back. And the problem is, the heap is used very commonly to make less memory use, but if you accidentally free the same segment twice, then you end up with a pointer, you end up with an operation that writes to a strange part of memory that can be exploited. And if you forget to free something, then you have a pointer, a dangling pointer, pointing to memory that is no longer in use, and you can write to it and change the contents of memory that might be used for another purpose. And you end up with essentially the same vulnerabilities as stack overflow. Those are heap overflows. So to prevent this, they just pin automatic reference counting, where it counts how many times did you allocate it and how many times did you free it, and I'll do something about it if you didn't free it once for every time you allocated it. It sounds pretty good. There's a similar problem in Windows, which are DIL files. If you install stuff on Windows, even Windows 10, it'll say, I'm missing x4739.dil. Go find that somewhere. There's all these websites, download the DILs you need. That's because Windows doesn't have this for some ungodly reason. When you put a library file in, which is a DIL, and then you install software that uses it, and then you install more software that uses it, you have like 4 different programs using the same DIL. When you uninstall one, it might nuke the DIL, and it might not, or it might pop a box saying, I'm using x473.dil, should I delete? And I'm like, what am I supposed to know? How am I supposed to know whether you delete it? It might still be used by something. I said, fine, and you expect me to figure that out? And you know, in Linux, they don't do this. In Linux, there's a thing called the link count, which counts how many handles are pointing to this file. So every time you install another program that uses a library, the link count goes up. And every time you delete one, the link count goes down. And it knows when nobody's using this file and it's time to delete it. But Microsoft did not get the memo. Anyway, that's what this thing does, some version of that, which helps moderate those heap corruptions. All right, so now just like everything on your phone is incredibly encrypted, and the operating system itself is very heavily encrypted, so are all the apps, because everything on the App Store is worth a lot of money. People make real money with iPhone apps. So that stuff has digital rights management to make sure you don't make pirate copies. So everything in the store is encrypted, and when you run it on your phone, it has to decrypt it. So if you can jailbreak your phone, you can steal the memory from the decrypted version. And this is how I used to crack those games, the Commodore 64 module. You would just do a memory dump of the running game, and then you could put it on any kind of memory storage and have like a cracked version of the game. You know, it's a pretty deadly attack. There was a particular brand of television about 8 years ago, I think a Sony or Zenith television, where you could play like this content protected digital rights management TV, and there was a wire where it was decrypted, and you could drill a hole in the side and put in a jack and record the decrypted stuff. And people bought that special TV just for that reason, just like they buy the special insulin pump just so they can hack it. This became a well-known underground fact. Oh boy, you can totally pirate content easily with this TV. Anyway, so what you do, you run the app, then you go good old GDB, the GNU debugger. We're going to use it all next semester. It's my best Linux debugger. You attach to the running process. Now you use info to find out where the memory segments are, and then you dump the memory. Now you get a copy of the unencrypted memory, and this is what I thought was awesome. You take the original app on your file system, and you just write over the encrypted memory with the unencrypted memory, and now you've got an unencrypted version of the app. Now that's pretty elegant. And if you take the cryptography class, we did that with Python and the Penguin. We would take the Penguin, dump it as a binary file, then encrypt the middle of it and write it on top of it, and now you have the encrypted Penguin. You don't change the header. It's the same process. You know. Anyway, so Yeah, there are tools that automatically do that for you. Of course, that's not super complicated. There's a dump decrypt and BF decrypt and various other ones that work for different versions of iOS, but you need a jailbroken iPhone. All right. Now, once you have got the decrypted binary, you can analyze it at various different levels. The low-level simple analysis is to use class dump. This gives you sort of like the Android manifest file kind of thing. It shows you this mess. It gives you a list of all the method names and variable names, which is a long list of thousands of items. This is for some popular app, I think the Starbucks app or something. But you can just read the names of methods, the names of variables, names of libraries that are used. And you could even change the external hooks to those libraries to tamper with it in simple ways. But if you really want to understand it, then you put it in a real disassembler like Hopper or IDA Pro, just like you would with a real Windows executable. And then you see the raw binary and you can figure it out and modify it. And this is quite naughty to do. Here's the Starbucks app. Starbucks app gives you a discount if you have a card. And there's a module called Fake Card. To test probably, there's a function in the app that generates a fake card. So of course that would be cool to like add a button that makes a fake card and then you get a discount without fulfilling whatever the requirements are. So there's a blog where a guy shows how to do this in Hopper. And like I say, next time I teach this class, we'll have to hack some apps. I had some simple projects like that too. It's very much like the process with Android, except you have to really be down at the binary level with a real disassembly, which is a lot more irritating than say APK tool. But you get used to it, and we'll be doing that next semester in the malware analysis class on this kind of thing, and in the exploit development class in GDB on Windows and Linux. On Linux, not Windows. Anyway, so that's as far as we're going to go. But I'm glad to see we didn't cover in any more detail iOS hacking, but I hope you can see it really is very much like what we did on Android. No general new concepts there. All right, so let's do a Kahoot. And that'll be it. See how many people I got online? Oh, 8 people online, maybe 6 or 7 in the room. That's pretty good. Okay. Although last night we had 8 people online and still only 3 Kahooters, so I think they were actually all asleep. But anyway, but they don't pay me by the student, which is good. So they don't pay me by the grades either. When the first time I taught the hacking class, it was a 1-unit internet safety class, and I had 30 students, and all the projects were setting up a Windows XP virtual machine and infecting it with all the horrible stuff we could find, and then trying cleaning tools to clean it, see how clean it got. And people thought that was great. And all 30 students got an A. And I said, are they going to do something to me? They didn't do anything to me. All you had to do was like 6 projects, and there were like 6 extra projects, and they all did everything because at that time, virtual machines were brand new, and deliberately infecting things was fantastic. And we were all just very happy to do this stuff. Anyway, so I could give you all A's. I suppose I could give you all F's. I have great power. Anyway. Well, there are extra credit quizzes. There are 2. I think there are 2 extra credit quizzes in this class, and there's 1 in the cryptography class. There's a few of them.
There's one in the Monday class.
I don't think there are, no. All right. Anyway, guess I can go. I guess 9 is the number. Oh, there's more coming. Okay, wait a few more seconds. Mind-boggling. Yeah.
Like you said, they fell asleep.
There's a lot of mind-boggling stuff. Like the IDA Pro is pretty mind-boggling at first. We're going to switch IDA Pro with Ghidra largely next semester because Ghidra is much nicer. IDA Pro just makes you want to cry and give up the first couple times you look at it. You have to sort of ease into it gently. Photoshop had the same effect on me. I remember, like, I opened Photoshop several times saying, oh, I'll just crop this image, and I said, oh my God, I'll just give up and not do it. Hopefully there were the panes and the levels and like 10 toolbars and buttons. I said, what is this madness? Anyway. I lost them. I better go now before, okay. They're falling asleep, dropping dead as I wait. Okay, so.
Lost signal, man.
Yeah, all right. So, okay, which key is controlled by the TouchID? Okay, it's the wrapping key. It's wrapped around the other key. All right. What's the binary format for an iOS app? Okay, that's MockOh. All right, what's the key in the hardware-based crypto accelerator? It is the UID key. I don't know why there's a separate thing called the device key, but there is. It is really very complicated. All right, which feature presents heap corruption? Okay, that's the ARC, automatic reference counting, to make sure that you aren't freeing things twice. So, Jeff, Tom, and Carrie, good, okay. And Pink.
That's me, that's me. Oh, that's Carrie, I'm Kay.
Oh, okay. All right, so Carrie is Pink. All right, and you're Carla. Okay, good. All right, fair enough. All right, well, that'll do. You know, if I was more scientific, I'd give you more points for being one, and then it would count. But anyway, I'm too sloppy there. Okay. So I guess that's it. I'm going to stop the share, and I'll go upstairs, see if anybody wants help on projects. Let's see if there's any chat messages coming in. Okay, thanks for the remote access. Good. Okay, good. Yeah. Well, I'll see you folks next semester. If you want to come back, we'll have more of this stuff.
So where are you off to, though?
Oh, man, I'm going, next week is Illinois, and then Los Angeles, and then China. And after that, they want me to teach in Jordan.
What's in Los Angeles?
And I just got a gig in Jordan. So,
Jordan.
yeah, I've never been any of these places, but all I do is I check online. There's a line of how much we hate nations. There's a list. And I found out Jordan, we like Jordan. Jordan's on the same list as Saudi Arabia. Jordan, Saudi Arabia, and Japan are all like B1 countries, and you can totally do anything with them. They're like friendly. Russia and China are like H1 countries that we're pretty hostile with, especially lately, China. And so there's limitations on what I can teach there. But I can teach anything in Jordan, so that'll be fine. Anyway, okay. Yeah.
When you try out the Google beef noodles.
Oh, okay.
The
Yeah.
Igua, the muscle, Rika something.